Okay, so we are in chapter 6 of Halliday. So chapter 6, problem 16, Halliday 9th edition. Very well. And what we have there is an incline, and we have to take friction into account. So let's try to make our drawing. Here we have our incline. We have an object here. Doesn't matter, they talk about penguins and so on, but the fact is that they give us the weight of this object. Instead of giving us the mass, they give us the weight of this object. So mg is 80 newtons. And let me already take this chance and draw this force, which is pointing down. Here we are, we have our mg. And let me extend this incline. All right, so there we are. We have our force mg. What else do they tell us? They tell us that this incline has this angle. This angle here is 20 degrees. And they talk about coefficient of static friction and coefficient of kinetic friction. So static friction, this coefficient of static friction when we are not moving is 0.15. The coefficient of kinetic friction when we are moving is, just the opposite, sorry. So let me correct this. The coefficient of static friction is 0.25, yeah? And the coefficient of kinetic friction is 0.50. All right, so there we are. And then comes, what is the least, so the first question, question A, what is the least magnitude of that force? So we have a force being applied here. So what is this least force, the magnitude of this force parallel to the plane that will prevent this lead, this object, from slipping down the plane? Okay, so what is this minimum force so that this object is at rest? At rest, so that this object does not roll down, does not slip down the plane. Okay, what are the other forces that we have? We have normal force. So let me draw here the normal force perpendicular to the plane. And if it's not going to slide down, what wants this object to fall, now to go along this incline, down along this incline, is gravity. Now is the gravitational force, is the component of the gravitational force along that incline. What is going to prevent the force, this external force that we are exerting, this F, and also the friction force. The friction force can also help us. Okay. So the friction force opposite to that tendency to slide down would help, together with my force, will prevent this object from sliding down. Okay, so it's at rest, this object. Friction and my force is helping that. Okay, and what we want to find, what is this minimum force? What is that F? Okay, so to do that, I'm going to choose a frame. Well, let me put a frame here. Along the incline, if the motion happens, it happens along the incline. So it's nice to have the frame along the motion, so it along this X direction. And here is our Y direction, right? So our Fn is already in the Y direction. The force that we apply is already in the X direction. Friction force is already in the X direction. So everything is good already to go except for the mg. Mg is not along any of the axes, and mg is the one that we'll have to decompose. To decompose mg, we need to know the angles around that force. Okay, remember we talked in class, if you think about this triangle here, this is 90 degrees, this is then 90 minus 20, this is 70 degrees, and therefore this is 20 degrees. So think a little bit more, go back to our discussions and be convinced of that. I'm going to use that 20 degrees there. So I'm going even to delete that 70, okay? And I'm going to focus on that 20 degrees to decompose my force mg. How do I decompose? I need to make my triangle the mg is the hypotenuse of my triangle. So I'm going to make my triangle along this frame to decompose that force. So how do I do that? Well, I make a line here parallel to x. I have this line here parallel to y. So this component here is the mg along the y direction. This is the component of the mg along the x direction, okay? The one that is along the y direction, this is adjacent to 20 degrees. So this component in the y direction, since it's adjacent to 20 degrees, this is mg cosine of 20 degrees. And these are the part, okay? And these are the part that is opposite to 20 degrees. This is mg, opposite is sine of 20 degrees. Okay, so just for you to know, the component of the gravitational force that is in the y direction is the cosine. In the x direction is the sine. Cosine in the y direction because the y component is adjacent to 20 degrees. Sine in the x direction because this is opposite to 20 degrees. All right, with that, let's go for the equations. What we want to find is F. I'm going to start looking at the sum of all the forces in the x direction equals to MAX. All right, what do we have in the x direction? Positive, pointing the x positive direction of the x, I have the force that I want to find, the F. I also have friction force helping me. Right? The object would be sliding down. Well, the friction force would be there opposite to that motion. And so the friction force is uphill, up along that incline. And what is it that is trying to bring this object down is the component of the gravitational force, is the component of the weight in the x direction. That is opposite to x, to the x frame, the direction of my frame, that is minus mg sine of 20 degrees. Okay. So this is what we have in the x direction. And what else? Well, that's all. These are all the forces in the x direction. What should I put on the right side? Well, as I said, we want to find the minimum force so that this object is at rest. So on the right side, we just have 0. Okay, so you see here in our equation, the unknown, the force that we want to find is there. mg, we have this mg, he is given to us is 80. They gave us, and sine of 20, we can just compute. Well, what is on our way there is the friction force. Okay, but we know what friction force is, right? We know that friction force is me, the coefficient, and Fn. Now, which coefficient? Since we are thinking about rest, this is the static. Okay, so let me rewrite this equation. Things are looking better. We are getting there. Force. Then we have the friction. So coefficient of static friction multiplied by normal force minus mg. We know what this mg is. Sine of 20 degrees. Okay, this is looking good, but still I don't have what is Fn. To find Fn, I need to go to the equation in the y direction. Okay, so let me put the equation in the y direction here. Sum of all the forces in the y direction is equal to the mass and the acceleration in the y direction. What do we have in the y direction? We have normal force. Pointing up, so normal force is positive. What else do we have? Only the component of the gravitational force, only the component of the weight that is pointing in the y direction, pointing down, opposite to the direction of my frame. So the component is this one, right? So what we have to put here is minus mg cosine of 20 degrees equals to what? Nothing is happening in the y, 0. Okay, so with that we found what Fn is. Fn is mg cosine of 20 degrees. All that you know, okay? You can put a number here. You know that mg is 80, and you you can get cosine of 20 degrees. But I'm going to carry it just to be elegant and put things in with simple. So I come back to our equation. We have F plus that coefficient of static friction. Now I'm going to put what Fn is. We just found is mg cosine of 20 degrees minus mg sine of 20 degrees, okay, equals to 0. All these are numbers. You can just put in your calculator. I'm just carrying things with symbols to be elegant and to give you the final form. So what is this force? Is mg. Okay, I'm putting everything on the right side. First, I'm putting this element here, so this term. So mg sine of 20 degrees, okay? Minus, I'm going to put this part here on the right side, it becomes minus, so minus mg. Then I have the coefficient of static friction and cosine of 20 degrees. So this is the number, the magnitude of that force, okay? But you could have obtained that already at this step, and here you could have put numbers already if you don't like to carry symbols like that, okay? This is part A of this problem. I'm going to do part B in the next video, so this doesn't get too long, okay? Part B of the problem will be in the next video.